All right, number 19. You have two equations. We have a system of linear equations, and we're solving to find the ordered pair by using substitution. Now, if you noticed, in 17, this was the equation that we had to solve for y, and in 18, this was the equation we had to solve for y. So these are not solved for y, so you should have just used your answer that you got from 17. So this one solved for y is y equals 2x plus 5, and this one solved for y is y equals negative 2x minus 7. So we set mx plus b equal to mx plus b. We took this, and we set it equal to this, because that was the solve for y. So we have 2x plus 5 equals negative 2x minus 7. So we have to get the terms with the x on one side. So what we went ahead and did was we added 2x to cancel here, and then we said 2x plus 2x. Well, that gives us 4x. We drop down our plus 5, and we drop down our negative 7. So we have 4x plus 5 equals negative 7. We need to get this 4x by itself, so we need to subtract 5 from both sides. It cancels here. Negative 7 minus 5 gives us negative 12. So 4x equals negative 12. We divide by 4. Negative 12 divided by 4 gives us negative 3. And that is our x value. Now, what we have to do next is we have to pick an original equation, just in case we didn't solve for y correctly. We needed to plug into an original equation. I chose the top one, negative 4x plus 2y equals 10. I plugged in negative 3 for x. So here we get positive 12 plus 2y. To get y by itself, we had to subtract 12 from both sides. 2y equals negative 2. We divide by 2, and we get negative 1 as our y value. So our coordinate point should be negative 3, negative 1. But we can check that by plugging it into our original equations like this. We plug in our x, we plug in our y, and we notice that they both check out. So this negative 3 comma negative 1 is our final answer.